This is Serving It the Absinthe way. We'll be talking about GraphQL, Absinthe, Dataloader, with a pretty big emphasis on video games. A little bit about me. My name's Aaron Votre. I'm a developer at Corvus in Boston. We do InsurTech and some fun things with data to predict loss and insurance. And we've been using Absinthe and Elixir for like a year, almost and a half since we started. And I actually came and did the GraphQL class last year and was so excited about it all year that I've been waiting for an opportunity to do something like this. So hopefully I can get you guys as excited about Absinthe as I was. And that is why I'm here. That goal is a little nebulous, so we'll do some more concrete objectives and hopefully prove that first kind of make-believe goal for you guys. And I feel like the best way to learn any of this stuff is by doing a project, and we will build an app together right now. So, some context. These are my friends, RJ and Sam, and we make browser games whenever we want to learn something new or just have fun in general. This is our fun activity. And we have 2 hit games right now, Supervirus 1 and 2. The first one got so much feedback from our friends that we really needed a way to share scores. And so this is going to be our first back-end project for game development, where Supervirus 2, which is still in beta, is going to have a live updating leaderboard, and we're almost there. So to start, we're going to have players, games, and scores. That's all we're going to model. Pretty simple. Hopefully this server can work for future games also. So that's why I'm saying games, plural, even though it is just for this one specific one. And we just need to persist that and explore it. To be specific, we don't make games together. We just host them together because we're lazy. So I want this API to be super easy so that Sam and RJ can also use it and don't need to come to me for help whenever something goes wrong. So some starting gear. It's going to be a pretty basic Phoenix Ecto app, Postgres. Phoenix, our go-to web framework, we are just going to use it for routing, so there's not going to be anything special there. Ecto database wrapper, also going to keep it super simple. We'll have a couple schemas, they'll have some tables, and we're going to do nothing special other than defining those relationships. And that leaves Absinthe, and hopefully we are just going to be able to focus on it the entire time because the rest of the app is so simple. A little bit about what Absinthe is, for anyone that's newish to it. It is the Elixir implementation of the GraphQL spec. GraphQL is a query language for APIs. That's what the QL is. And it's supposed to provide a complete, understandable description of your data and give clients the power to ask for exactly what they need, which for me means there's a lot less burden on my shoulders. I am going to define the graph, and then I'm going to let the API users ask for what they want, and the server will do its best to return that. I'm not here to pitch GraphQL at you, but it's super cool compared to REST, and is going to allow us to ask for as many resources as we want in a single request. And you get to ask for exactly what you want, and we're going to keep coming back to why that's awesome. So I've got about a little more than 20 minutes to get this server working, so we're just going to dive headfirst. Oop, or not. So standard Phoenix convention kind of thing. We're going to have a games context. We're going to model the player and the game in some pretty standard schemas. They'll have IDs and tables and just a name string. Very basic. We're going to have a score, which is a tiny bit more interesting. It's just got a total and it's got some IDs, one player, one game. That's it. Now we can navigate across everything, and you can imagine what the ecto schemas would look like for these. We'll hopefully not come back because it's going to be super simple. Also, imagine now we have our Phoenix app with no front end anything. This is just going to be an API and a blank Phoenix router. So we're going to jump in to Absinthe. You can get it working in a single file, and it's going to be called the schema. This is the home base for Absinthe. Everything you need is going to be in here. This is where we basically define the graph with text, and you should hopefully be able to scan over this and assume what the graph would look like. So some of the specific things, this is in our scoreboard web context because it is just a web interface. Like that games context was meant to manipulate all of your data. This should just be defining the associations, and that's it. We have objects, which this one is a game. I think I can scroll over here. Ooh. So we define a game object. It's got two fields, an ID and a name. These have some types. This is a node in our graph. And to get things started, we're going to have one node. And next, we have this query block. This is called the root query. And everything in here, each field, you can imagine being an entry point into your graph. So once you're already exploring, you can go anywhere where there's a connection. But to get in, we want to kind of limit the doorways. So this field is also going to be called game. It moves us into a game node. It takes an argument, and it resolves by going to our context and getting the game with that ID. Very simple, not a super exciting graph with a single node in it that only has two fields, but it's enough to get us started working on something. So on the left, we have some actual code for posting to the API and getting some of this data. One of the most important parts about GraphQL is we want this client query to look exactly like the data that we return. So matching the schema, this is the game entry point, taking this one parameter, which is going to look a lot like a keyword list. And once we go through this curly brace, you can imagine we are in the game node in that graph. And the only things available are ID and name, so we'll get them, but we've got nowhere else to go after that. So we want to expect something like this back. We could post this all the way through Phoenix and get some real JSON back, or we can send this directly to the Absinthe schema, and for testing, that makes things a lot easier. So the important thing is we have this game key, which has a map with an ID and a name. This shape should always be the same, and that's what makes it so useful for a client. And hopefully, we can demo that. How tiny is that for you guys? Good. Very tiny. Good. It's very tiny from here, too. So let's make that a little bigger. OK, a little better? Great. So this is that exact same query. At the top, we have the request with a real ID in it. And the blue output is just some database logs. That looks right from here. Like we go to the games table, and we get one thing. We return a result, and it looks like SuperVirus 2. So we're off to a good start. Now, let's just keep building the graph. Like getting to one node is definitely exciting because it takes no time, but it's useless to Sam and RJ when they want to use this API. So we can define other nodes in that schema file the same way. You use the object macro. We're going to add a score. It has an ID and a total. Now we have two nodes in our graph, and the last thing to do is define the edge between those nodes so we can actually start exploring. And so that is just going to be a field like any of the others, and it's going to be a little bit more interesting. The type is going to refer to the other object, and we're going to have a resolve function, and that's going to tell Absinthe how we return this data. When we want to go across this edge, what does it have to do? So let's jump into resolvers. This resolve is resolving the key name on that node that you're in to get to the next place, which for us is just ecto, right? We just want to take that ID, go straight to the database with it, and return it. So a resolver can be any sort of data. It can be static. It can go to an outside API. You can do whatever you want. For the sake of this, we will just stick with ecto. So let's write one of these for that list of scores. Here, we are just going to use our ecto score model, or score schema. We're going to get all of the scores that are associated to the game node that we're currently in and return them as a list. The really important thing here is that the first parameter to this is a game, meaning that your resolvers know where they are in the graph, and that is how you navigate around. So imagine now we've added some of those simple resolvers everywhere, all of the edges, and I also added the player really quickly, which is the same as a game. Describing this query on the left, it's the same entry point where we're going to get that same game and the name, hopefully SuperVirus 2 instead of Code Simulator. And we're going to get that list of scores. And on each one of those scores, we want the total and the player's name who saved that score. So we're going to expect some data back, just like this that we saw before, except scores is a little more interesting because it's going to be a list of these return data. And let's go look at one of these. OK, that's a lot of blue. Good. All right. All the way to the top, we have the white text is that same query. I asked for the IDs also, but that's not important. We want all the scores and the players from an actual game. And then we have a big wall of blue text, which we'll get back to. And at the end, the important thing is the shape is all the same. We've got a game. We've got some scores, which is a list, and there's a bunch of results in there. So looking at all of this blue, I can't see my cursor over there, but I bet there's a bunch of lines that say from the players table. And you will just have to take my word on that. So what happened? There is the word player in here, so that's probably where the problem is. And we got to the players from the scores, so that narrows it down some more. And it's interesting, this looks a lot like an n+1, but I definitely didn't write one. So we'll investigate that just a little bit more. This is what the resolver looks like that I wrote for player. It's pretty simple. It's exactly like the other one we wrote, where we're going to get the ID off of the score node, which we have, go to the database and get that data, which is exactly what I said we were supposed to do. So this seems pretty right. What could I have been doing wrong? When I was trying to figure this out my first time, I had to draw it out because I'm a visual learner. So I'm going to take you guys through that now. This is how I imagine the entry point to the graph. We're in a game, and we want to resolve those scores. Well, we wrote that query. We know it's just one query, and it returns a bunch of scores. And then we have the next resolver, which gets a game for a single score, or a player for a single score. So that's good. And then that keeps happening over and over again. And it seemed fine when I wrote it, and now it seems less fine when I kind of draw it out. So we're going to have as many queries for players as we are for the number of scores we found, and the one to get the scores. Yeah, it's an n+1, and it was my fault. All right. So we need a new strategy. Traditionally, we preload, right? We know this data is coming, so we'll just load it ahead of time. But we're getting dynamic queries in from the client, so I can't always know what's going to happen. So we'll have to think of something else. What exactly is happening? Well, we end up making kind of the same exact query for that player over and over again for all of these score IDs. So I think there's probably a way where we can handle this. If we batch all of those queries together and then run a single query for all of those scores, and then we'll pick through those results and distribute them instead of having to query every time. So that makes sense in my head, kind of. We'll draw it out. So this is where we were. This seems safe. We got all of our scores. Instead of making the query when I want to get the player, I'm just going to put it somewhere, hang on to it for now. And I'm going to mark that first score and say, I was here, but I'm not done. And then we're going to keep doing that. And then once I'm all out of scores, I want to run a query. I want to say, where are all of these players belonging to all of these scores? One big query. Awesome. I've got a big pool of players, and all I have to do is go back through those scores and associate them. Great. Pretty simple, kind of. Making the visual took way longer than you might think. But that seems like a lot more steps. There's just a lot of code involved in doing all of that. But the more we think about it, loading, collecting all of those IDs, that's probably going to be pretty similar in all the cases. And getting the results from that list of results from the query, that's also going to be pretty normal. And then we have the run step, which that can definitely get confusing. Luckily, Ecto is pretty good at building queries, so let's move into how we would do that. Dataloader, conveniently, provides an easy way to efficiently load data in batches. So that was a lifesaver. It's a small library that does exactly this. And it can definitely be a little bit daunting because conceptually and writing the code for batching is not easy. But we can make a Dataloader work. You give it a source. For us, it's going to be our Ecto repo, and some rules. When should you do certain queries? So building one is going to be pretty easy. This code is the stuff we would put into our game's context and not into our schema. So we're going to return a new Ecto type data loader. We're going to give it that scoreboard repo, and then the query to function is going to be like our rule book for this data loader to get data back. And the nice thing is, you don't even have to give it any rules to work. So you could just make it out of the box, start running queries. And for the sake of showing you, it's really easy to add more rules because you can just pattern match on all of them. So this will at least save us from blowing everything up by adding that limit. So this first resolver, which is fine. It works. It's definitely great if you are trying to prove a concept. And they'll even work as long as the thing you're retrieving isn't on the wrong side of a list. But it's a lot more, or a lot longer than using a data loader, which is going to be efficient and simple. And when you're scanning through a schema and you see just some one lines with some keys, it's very obvious what's happening. And you trust that data loader is handling this batching for you. So in this example, we want to get the player off of the score, and we're not really telling data loader how to do anything. It's because that player key is the same player association in our Ecto schema. So we would, before, in the above part that's striked out, we were specifically saying, oh, get me that player ID off of the score struct. But We don't need to do that. We've already defined that association in Ecto, so just let Dataloader handle grabbing that for us. So batching is efficient. Batching is a conceptual move. Dataloader is a way of writing that code in a really simple way and a very legible way. So we'll go back to that original query where we want to get all those scores and all the players, and we'll swipe over here. So from here, this is the same app running with some data loaders in there instead of the original ones. When we run it here, we're just going to get one query at the bottom. I can't see my cursor, but the last blue line should be going to the players table, and there should only be one select statement going there. But we're going to get the exact same result set as we did the first time. And when I go back and look at my schema, it's like 100 lines shorter. So this is good. This is keeping us efficient, and it's also making everything more readable for the next person. And I mentioned that you can explore this. Well, one of the great parts about the GraphQL spec is that everything should be introspectable. And that means we can basically have an IDE for writing these client queries. So this is called graphical, where not only can you just type out your queries and see them run, this is running on a Heroku server, or hopefully the Wi-Fi is good enough for me right now, where we can actually go to each of the nodes in the graph, see what's available, see how to jump to another node in the graph. We can move to some more exciting queries, like actually loading the leaderboard. Okay, right? And we made that exact same query. We saw the log output from the database, so we know this is working on the back end. And this is like actually a useful set of results. And the client-centric aspect is that we can also just make any kind of query we want from here and test it out. This one being all the scores for a specific player. And you guys can mess with this live. The link is in the repo notes. So I think I'm cruising through this. But that was about 20 minutes building your first Absinthe API and using Dataloader. One of the important things I want to push is that you should use Dataloader early. I was definitely afraid of it, and batching was confusing, but Dataloader has been making my life easier ever since starting this project. So we built the graph in the schema file. That was pretty simple. It's one file to define the graph. We understand batching, which keeps the app efficient. Dataloader is going to keep it low on the code side, and you can explore everything. There are like a ton of tools. Graphical ships right out of Absinthe, and that app is even serving it in the browser. So you should be able to, hopefully, make your own Absinthe API right after this. And I have links all over the place to the repo and the slides and different apps. So please come up to me after, ask questions if you have them. I would love to answer questions if you guys have them too.
Awesome presentation, by the way. So I'm curious, how does Absinthe handle like user authentication and permissioning on the graph?
Okay, so auth is interesting. It's definitely different. You can still have your normal like Phoenix token general auth, and then the way that we generally do it is node by node. So based on a user role or any association you want, you can say, oh, you're going to have access to these fields, or even whole chunks of the graph are only going to be accessible to some users.
Are there any situations in which Dataloader would not work for maybe like a front-end framework or what you're looking to do, where you wouldn't be able to use Dataloader for your batching?
It would be hard to say no to that, but it is more flexible than just that example. That is like the most default you can possibly make it because I wanted everything to fit in one slide. There's a lot of flexibility where you can actually go into more detail on what happens when you're loading, what happens when I'm running this query, how do I split up the keys at the end. There is an even longer form of answering these questions just like Dataloader. So even if you're using Dataloader, you don't have to use it in that form. So it gives you the flexibility to make it far more complex.
Hi, great talk. I have a question in that example you gave with the games and scores and players. What does the Phoenix router look like? Is it one route that you're kind of issuing these requests to?
Yeah, I might be able to show it to you. Oh man, if I could see this at all. But yes.
Okay, so it's forwarding over to Absinthe.
Yeah.
Okay, cool. And then I guess a follow-up to that, I've been seeing a lot of GraphQL out there. It's kind of a big thing that's going on ever since, for a while now. I haven't taken a lot of time to explore it and kind of figure out what it is. If you could sell me on GraphQL or Absinthe in general, what would be kind of like a good problem that this would be a good solution for?
Okay. Well, my personal one was like, I want to make a server and have fun writing it. So like that sells me. But if you have a variety of client requests, or you have to, every time a new feature request comes in, you have to make a new REST endpoint, that is a huge hassle that kind of goes away when you define a graph that anyone can use in any way. So if you have lots of separate API users that you don't control, that's like a great use case. Definitely a more business use case than mine, but if you're trying to sell it to your company, that would probably be the time.
Is it possible to use Dataloader with things that are more than Ecto?
Absolutely. So Dataloader with Ecto is just one like use. I think the original one is a key value store, so you can build basically anything as a batched like operation like that, including outside APIs or anything you really want. I haven't explored any of the other ones because Ecto makes it so easy that I was like, this is going to be the best way to make a talk out of it.
So I have one more question. Are there any specific considerations or gotchas to handling mutations with Absinthe, or do they work pretty much the same way as like the queries work?
I have not run into any concerning gotchas on mutations. Yeah, they're really nice because you can do your mutation and then continue with a full query from the node that you wanted to mutate. So yeah, very similar.
Is error handling fairly straightforward for that? Like
Sorry?
Is error handling fairly straightforward, like if the mutation blows up somehow?
Yeah. In those examples, I was just like default returning an OK tuple with some data, but you can return errors. There's like a variety of approaches to that too.
Any more questions?
Nope. Thank you, Aaron.
Thanks again.